Hello, and welcome to Designing Impactful Innovation. I'm your host, Clara, and today we're talking about digital continuity in the robotics industry with two Dassault Systems experts, Dorine Tabouret, Industrial Equipment Industry Solution Experience Consultant, and Alexandre Clément, Industrial Equipment Industry Solution Technical Consultant. Hello, Dorine and Alexandre. Welcome to the podcast. Thank you for joining us today. Could you please tell our listeners about yourselves?
Hello everyone, my name is Dorine Tabouret. I've been working in the industrial equipment industry at Dassault Systèmes for more than 3 years now. I'm responsible for defining the strategies to implement our external CAD customers on the 3D Experience platform. That means help our customers integrate their data on the platform by connecting this data from the legacy to the platform and using it across experimental disciplines such as product engineering, manufacturing engineering, and service engineering. Working on the 3D Experience platform is most of the time a real business transformation at the customer side. So our challenges at Dassault System is to understand how to improve our solution based on the customer's way of working and the customer's use cases, to understand how to implement and reuse those legacy data on the platform thanks to our connectors to connect the data on the platform, and also how to use legacy data in supplemental disciplines like simulation, fluidic manufacturing, and service.
Thank you, Doreen. Hello, everyone. My name is Alexandre Clément. I've been part of the industrial equipment team also for 2 years now, in charge of the robotics subjects. The objective is to be able to address robotic topics with our solution from the free experience platform. The market is competitive and demand is growing around the need for simulation upstream, the upstream of robots. Indeed, from design to integration into the virtual twin, everything must be tested in order to minimize the risk of error. I am therefore in charge of the development of our portfolio by working both close to our customers to understand needs and know how to replicate them, and also at the same time close to the R&D for development requests.
All right, thank you. Before we dive in, could you please explain what digital continuity is and why it's important?
Yes, sure. So in industrial equipment industry, our customers evolving in a highly complex and competitive environment. So they really need a unique solution to manage every type of data everywhere and with everybody all around the world. So why is digital continuity so important for industrial equipment customers? Thanks to this digital continuity, they will be able to break down the silos within the company, so between the different departments like engineering, manufacturing, service, sales, or purchasing, for example. And so they will be able to work on the same data and to access the same data on a secure environment. For example, we know that for most of our customers in industrial equipment, there is a real discontinuity between the engineering world and the electrical world and the rest of the business departments. The challenge here is to manage in an easy way multidisciplines engineering with hybrid structures, for example. Thanks to the 3D Experience platform, our customers will be able to work on a unique solution to engineer, produce, and service fast anywhere. Our 3D Experience Platform Cloud offers different things. First of all, a secure environment, then an easy deploy and user-friendly environment. Our customers don't need other things than an internet connection, so very important. And they always work on the latest release of the solution, what we call the best so far, because they are working on the cloud. The most important point also for large companies with several branches all around the world is to have a platform that will fit well with their new way of working since the COVID pandemic, for example, with the increase of the people working from home.
Thank you for that, Doreen. Now let's zoom in on the robotics industry. Could you tell us about the challenges faced by robotics manufacturers specifically and how digital continuity can help in that respect?
Yes, sure. Actually, there are different types of challenges around industrial robotics. In terms of safety, as a first step, industrial robots must be designed to operate safely in close proximity to human workers in the factory. So, This requires security measures that we must test upstream before any real integration. A second very important point is the notion of flexibility. Production environment can be dynamic and require robots to adapt quickly to meet changes in demand or configuration. Robots must be able to adapt to these changes efficiently and without major disruption to production.
Yes, as Alexandre mentioned right before, it's very important to be able to manage in-demand changes and configuration by promoting existing design and component reuse. So it is easier to manage those kind of topics thanks to the 3D Experience platform and to the digital continuity. Here we can do the link with what we call in industrial equipment industry the production of one business driver. So the emerging technologies of the fourth industrial revolution enable manufacturers to connect the needs of the market with the production system. Now, industrial equipment customers need to adopt smart and flexible business models in order to provide customization while also offering mass production capabilities. What we call the production of one enables manufacturers to adapt market changes and to the customer's requirements by providing customization value as a mass production deliverable. Flexible and smart production supports and enables the delivery of customized products with accelerated time to market and competitive prices. So, thanks to our solutions provided by the 3D Experience platform, customers can develop and deliver the right products their customer wants when they want it and in a way that it is efficient and economical for the manufacturer. And also, because the machines are software driven, they can be designed to produce multiple types of products and save time and money. It's easier to push a new product forward for our customers. So, as you can see, here we are talking about several different mechanical disciplines: product design, customization, product reuse, and software. But on the platform, with only one business driver, the production of one, we can cover a lot of different disciplines. All those disciplines can only be linked by a strong digital continuity offered by the 3D Experience platform. Business department will be able to collaborate with each other and to share the right data, the right level of information. Here, I would like to take a quick technical example. On the 3D Experience platform, industrial equipment customers will be able to create, first of all, a product structure named engineering BOM. And so software items will be linked to this engineering BOM. So here we have the creation of a multidisciplines bill of material BOM. This product can also be customizable, for example. And so the engineering BOM will be linked to a configuration context that will illustrate the product variability. During a purchase order, we need to filter this structure thanks to the client requirements. During the production and service phases, this same engineering BOM will be linked to the manufacturing one and the service one. So thanks to one unique bill of material, we will have the link to 4 different disciplines on the platform thanks to the digital continuity.
Yeah, that's impressive. That's a lot to think about. Are there any other topics that robot providers should be aware of?
Yes, we can also address maintenance topics because industrial robots must operate effectively to maintain factory productivity.
Yes, right. Here I can mention another industrial equipment business driver. So, what we call the equipment as a service tackles those maintenance topics. So, many new technologies contribute to improve the efficiency of industrial equipment. So, by incorporating servicing requirements directly in the design phases, machines will be faster and easier to maintain. And they will also have a minimal downtime. So manufacturers need to keep their operations running smoothly in order to remain sustainable and to satisfy customer demands. Equipment as a service is a business transformation that puts servicing at the forefront of the industrial equipment product development process. Here, the equipment is designed to be maintenance friendly, helping to reduce downtime that can jeopardize customers' operating capacity. If I go back to my technical example, On the 3D Experience platform, we have this one unique bill of material, the engineering BOM, which will be linked to multiple other objects like manufacturing and service items. If we want to focus on this service bill of material here, the service BOM will be composed of sellable items, and those sellable items will be linked to preventive maintenance plans.
We can also mention the costs of purchasing and installing industrial robots, which can be high. Additionally, there may be ongoing costs associated with staff training, maintenance, and system upgrades. Added to this are the different types of robots, which vary depending on the application carried out, the working environment in which it's implemented, or if it must be close to human, for example, and so on.
All right. Doreen, you talked about how collaboration helps get different disciplines to work together and enable manufacturers to increase their adaptability. Alexandre, what can you tell us about the role collaboration plays in the robotics industry?
When a team is developing or selling a robot, it's essential that each member of the team can exchange and share all data related to the product, such as technical specifications, technological developments, or updates linked to testing phases, and so on. It's necessary to have different types of tool from the development of the robot until it's put on sale. Robot manufacturers have to exchange data using tools that are not always suitable for communicating correctly together. So sometimes an additional layer of development is necessary in order to establish good communication and avoid any loss of data between software or also between hardware and softwares. That's why a technical collaboration space adapted to this type of team is necessary in order to have a complete view of the progress of the project. This promotes exchanges within the team as documentation, 3D models, or data between tools.
Yes, exactly. And I could add that working in the same environment helps when you're working with different suppliers and stakeholders.
Yeah, and seeing as the production of a robot can involve a lot of different people, it really helps keep everything on track.
So, we've talked about the importance of collaboration and data access for robotics providers who want to tackle today's industry challenges efficiently. What steps can robot providers and manufacturers take to implement digital continuity in their company?
Very important question here. Before implementing digital continuity in their company, robot providers and manufacturers need to define crucial elements related to their way of working. So, first of all, they need to analyze their as-is processes, so their current way of working. Then they also need to define the to-be processes, so what the customer want to do in the future on the 3D Experience platform, with which kind of supplemental disciplines. They need to define the solution architecture to implement the legacy data on the platform and to be able to connect those legacy data on the 3D Experience platform thanks to connectors. They also need to be aware that working on the platform is a real business transformation. That's why the to be processes need to be well defined before working on the platform or migrating data on the platform. As I said, working and implementing the 3D Experience platform is a real transformation. It's not just related to the data, but also to all the other business departments. For example, the IT infrastructure and business organization will need to be redefined because customers will have to define new methodologies of working depending on, as I said at the really beginning, depending on the supplemental disciplines they want to manage on the platform. For example, the change management, the project planning, the documentation management, or the ERP integration. When those implementation steps are done, robot providers and manufacturers will be able to create an entire virtual twin of their equipment thanks to the 3D Experience platform. Maybe here I need to give you a quick definition of what is a virtual twin. So it's a kind of virtual clone of an entire equipment, here a robot, based on a 3D data. So, the goal is to apply downstream processes before the production phases by implementing supplemental processes to validate the design and the overall functionalities, like the electrical, the cabling, the flow simulation, or the virtual commissioning. A virtual twin can be simulated and modified through time before validating the final design or before modifying the real equipment.
So, Doreen, you talked us through the process of implementing a digital continuity approach. And what really stood out to me was the fact that it's a full business transformation. I'm also curious to know more about the virtual twins that you mentioned. Alexandre, could you please tell us more about how virtual twins benefit robot providers in terms of design, engineering, or simulation?
Yeah, sure. Improved development and design through virtual twins allows robot suppliers to develop and design their products more efficiently. Using advanced computer simulations, engineer can model and test the behavior of robots in various conditions and environments, allowing potential problems to be identified and resolved early in the development process. Yeah, we can also optimize the performance of robots by simulating their operation virtually in real situations. Engineers can adjust design parameters to improve the efficiency, accuracy, and reliability of robots before deployment in the real shop floor. Also, by using virtual twins, robot suppliers can reduce costs and development times, and by identifying and correcting issues early in the design process, companies can avoid costly delays and expenses related to physical testing and design iterations. Virtual twins allows robot providers again to offer personalized solutions to their customers. By modeling how robots behave in specific environments, suppliers can tailor their products to meet the unique needs of each customer. They can also be used for predictive maintenance, as I said, and optimization. By monitoring data from in-service robots in real time and comparing it to the virtual models, suppliers can detect potential issues before they become major failures and optimize robot performance by adjusting operating parameters in real time.
So, to recap, virtual twins are helping robotics manufacturers efficiently design better products, as well as lower costs and accelerate time to market. And something I found interesting that you also mentioned is that virtual twins are helping well after manufacturing is over, for example, for maintenance phases, as well as to optimize future products. So, from what I understand, it's really helping robot providers and manufacturers get the most out of their development process and create even better products later on. To conclude this episode, I'd like to ask you, what do you think we can look forward to from the robotics sector in the next few years?
That's a very good question. And I think that the coming years will bring new types of challenges around robotics that we must respond to, such as, for example, human robot collaboration. Collaborative robots designed to work alongside humans safely and efficiently will become increasingly common. These robots will be used in a variety of applications, including manufacturing, healthcare, logistics, and also agricultures, and so on. There is obviously artificial intelligence, AI, and machine learning in robots, which will enable them to acquire more advanced adaptation, learning, and decision making capabilities. This will allow them to adapt to dynamic environments and carry out more complex tasks. Also, as we know, robots will become smaller, more agile, and more mobile. This trend will drive the adoption of robots in new areas such as microsurgery, space exploration, industrial maintenance, and environmental monitoring. Advances in autonomous robotics and multi-robot systems will enable robots to work in a coordinated and collaborative manner to accomplish complex tasks also for all those domains. These systems will be used in applications such as logistic or agriculture, for example. All of this must have its virtual twin in order to be validated for questions of security, performance, cost, and flexibility. Automation will continue to expand across a wide range of industries, replacing repetitive and dangerous tasks performed by humans. This will bring significant changes to the labor markets and require workers to adapt their skills to work alongside robots and automated technologies.
Thank you, Alexandre. Dorine, what do you think? How is digital continuity going to help with these changes?
I think that thanks to digital continuity, customers will be able to create, as we said right before, a virtual twin per robot in order to test those new hybrid environments by being able to simulate the interaction between the robots and between the robots and the human workers. So, very important for our robotics providers and manufacturers. I think another important topic is that customers need to collect the data provided by the robots working on the field to connect the field to the other disciplines like manufacturing or service. They also need to improve their products and they need to innovate thanks to the data collating with the collaboration and the reuse. So they will be able to design more profitable products and to deliver innovative products thanks to the data analysis. Thanks to robotics, industrial equipment customers can increase their competitive advantage by introducing new processes, product diversity, and innovation. An intelligent connected environment is one where machines talk to each other, include humans in a safe way, and continue to become smarter and allows manufacturers to respond quickly and accurately to the market demands. So, as Alexandre said just before, robotics are becoming smaller and connected to other systems and to humans. So, we all have heard about the new technologies like Internet of Things, the Industry 4.0, the Internet of Experience, artificial intelligence, and other things like this. This is really what's behind this new way of working, which is emerging in the industrial sectors.
Wow, so I guess we're going to see a lot more exciting things coming from the robotics sector in the near future. Thank you so much for sharing these insights with us, Dorine and Alexandre. I learned a lot today, and I hope our listeners found this as interesting as I did.
Thank you very much for listening.
Yeah, thank you.
Thank you for listening to Designing Impactful Innovation. To find out more, go to 3ds.com/cloud. Don't forget to subscribe for more insights and stories from our guest experts.